In this section, we're going to look at coordinate geometry and the basics of graphing. Okay. Coordinate geometry just means we're going to be looking at the Cartesian coordinate system and how to put points and lines and graphs in a pictorial form. Okay. So to start off, let's talk a little bit about the system. The Cartesian coordinate system is made up of two axes, our x-axis and our y-axis, and they meet at the point which we call the origin. This origin is usually going to be labeled 0, 0. Now again, the reason we mention this is because when you get further in mathematics, you will find there are other types of coordinate systems, and where you put the origin does make a difference. Okay, and you'll talk about maybe rotating axes and things like that. But for now, 0, 0 is the point of origin for our coordinate system. And it's broken up into 4 quadrants, first, second, third, and fourth. And these quadrants have special properties. So quadrant 1 is basically all the points, so the set of all xy, where x and y are both greater than 0. So all of your positive x values, all of your positive y values. Quadrant 2 is going to be the set of all points, x, y, such that x is less than 0, but y is greater than 0. Quadrant 3 is the set of all points where both x and y are less than 0. And quadrant 4 is the set of all points where x is positive but the y's are negative. Okay. So we'll have points that lie within different quadrants, but we also have what we call quadrantal points, or coordinate points, which land on your axes. And these have special names to them, and we'll talk about those in just a minute. But again, when we talk about points, we always think the x value first and the y value second. And to plot points, we're just going to treat it like a grid. We'll find the x value and then kind of coordinate off to get to our y value. So in this example here, we just want to graph some of these points. Okay? And here I'm going to show you how your graphs should look on your homeworks, or whenever you're asked to graph something. Okay? First thing you're going to do is you're going to lay out your coordinate system, and you should label your axes, so your x's and y's. But more importantly, you should also label what units you're going by, because some of your graphs are not going to be quite this nice where you've got small numbers. Sometimes you're going to have much larger numbers. So in this case, we can see I'm going by ones, and here again, if I go by ones, so there's my coordinate axis, and there's the start to any graph. Okay, usually if you're just asked to point plot, you should just label these and then put your points on there. Of course, label your points so we know which ones are which. If you're asked to graph equations, or circles or things like that, you should again start by labeling your graph, but then draw your scale so that it matches your picture. Okay, you should have at least 3 points on any graphs that you're given, and your graphs should represent what they are supposed to be. They don't have to be perfect. I am not an artist and I don't expect you guys to be, but they should represent what they're looking like. So for example, if my graph is a circle, it shouldn't look like a line. Or if my graph is a parabola, it shouldn't look like a cubic equation. Okay? Keep them relatively what they are supposed to be. Okay? Alright, in here, if we want to graph these points, I'm just going to label them all so we know where they are when we put one here. I'm just going to call this first one A, B, C, D, E, and F. Okay? So to graph our point A, we want the point 1, 3. So again, that means we're going 1 unit in the x-axis and 3 units in the y-axis. And I'm going to find where those two things meet. Okay. For B, -2, 2. So again, x being negative, y being positive, tells me I'm in the second quadrant. So -2 and 2. Again, if I coordinate there. For C, both x and y are negative, so I'm in the third quadrant. So over 1 and down 1. D is 4, 2. So +4 and then -2. E, I'm at 2, 0. Well, that just means I'm on my x-axis. So I have an x value, but I'm not going anywhere in the y direction. So there's my point E. And then for F, I'm at 0 on the x and then -3 on the y. So I'm on my y-axis. So there would be the graphs of my points. Okay, and that's it. Unless you're asked to actually connect the points into a line or some other graph, there's all you're doing. Okay. All right. There's two important formulas that go with just basics of Cartesian coordinate system, and those are your distance and your midpoint formula. Your distance formula is just what it sounds like. If I have 2 points, A and B, I'm just going to use the 2 drawn here. The distance between those points is, if I connect a line segment, I can then find the length of that line segment. Okay? And to do that, we're just going to take our coordinates, so I'll call A x1, y1, and B x2, y2, and I'm going to put them into a form like this. I'm going to find the distance between the x's, so x2 minus x1 squared, and then the distance between the y's, so y2 minus y1 squared, and add those together and take the square root, and that's going to give me my distance between those line segments. Okay. So here, if I'm looking at this particular picture, remember A was the point 1, 3, B was the point -2, 2. So if I want to find that distance, x2 in this case was -2, x1 was 1. For the y values, y2 was 2, y1 was 3. And so I'm just going to simplify that expression. Now again, remember, to simplify, we're going to use our order of operations. So -2 minus 1 looks like a -3 squared. Over here looks like a -1 squared. Remember, squaring those, that's just the square root of 9 plus 1, or the square root of 10. So my distance between my points A and B is just going to be the square root of 10. Okay. Now, we can do kind of the same thing. So I'm going to erase this D of AB that I have on here, that line segment. We already know that's the length of that line segment. But then, like I said, there's another formula that's useful, and that's our midpoint. So again, if I have these 2 points, A and B, I can find the point that's halfway between them and call that my midpoint. Okay? And to do that, basically I'm trying to find the point that's, again, halfway between both of them, so it's the average of the 2 points. Okay? So for a midpoint formula, we're just looking at the average of the x's and the average of the y's and finding that coordinate. Okay? So again, for these a's and b's that we have here, our midpoint of AB is going to be, well, we're going to add the x values together, so 1 plus a -2, and we'll divide that out by 2, and then do the same thing for the y's. So 3 plus 2 over 2, We can simplify. So here we can see that's a negative 1 over 2. And over here, 5 over 2. So there would be our point M. So looking at those special points we talked about before that land on our axes, we're going to look into those a little bit more detail right here. So these are called intercepts, and there's two types of intercepts. We have our x-intercepts and our y-intercepts. The x-intercepts are the ones that intersect our x-axis, and of course the y-intercepts are the ones that intersect our y-axis. And if we look at kind of the definition, it tells us how to find these intercepts. So if I'm looking at the x-intercept, we're looking for coordinates x, 0, meaning the y-coordinate is always going to be 0. And if we're looking at y-intercepts, then we're looking at 0, y, meaning that the x-coordinate is always 0. So if we're given equations, so 4x plus 5y equals 10, and we want to find the x-intercept, then what we're going to do is we're going to set y equal to 0 and solve for x. Okay, so in this case, I'm going to get 4x plus 0 equals 10, or 4x equals 10, which means that x will equal 5 halves. Okay. So given that, it tells us that our x-intercept is going to be 5 halves, 0. For the y-intercept, we're going to do the same thing, except we're going to switch the variables. So for the y-intercept, we're going to set x equal to 0 and solve for y. Okay. So in this case, again, plugging in x equals 0, says I'm looking at 0 plus 5y equaling 10, or 5y equals 10, so y will equal 2. And so this means that our y-intercept is going to be the point 0, 2. Again, be careful of your notation here. If we're asking for intercepts, it is not enough to say y equals 2 or x equals 5 halves. As you will see later, those mean different things. So when we're talking intercepts, we really do mean the ordered pairs given here. Okay. Another thing to talk about when we look at graphs is symmetry. And for us, there's 3 types of symmetry. By that I mean, once you get past pre-calc and you go into a calculus class or a advanced calculus class or even differential equations, some of those higher level courses, you'll start talking about other types of symmetry. And basically for symmetry, there's symmetry with respect to any kind of line that you can think of. For us, we're going to keep it the main 3. And so by symmetry, again, the best way to think of it is if I am looking in a mirror and I reflect across that mirror, it's what I see on both sides. Okay? And so if I'm looking at symmetry with respect to the x-axis, this means that for every point xy, there's a corresponding point x negative y. Okay? So symmetry with respect to the x-axis would be things like this. If there's this point here, then there has to be this point here. So it goes across the x-axis. For symmetry across the y-axis, that means for every point xy, there's a corresponding point negative xy. Okay. So pictorially, if this is my point xy, then the corresponding point negative xy would be in my second quadrant. Okay. So again, it reflects about the y-axis. And then lastly, my origin symmetry says that for each point xy, there's a corresponding point negative x, negative y. And again, that just looks like if I have a point here, there's my xy, then my corresponding point negative x, negative y would be over there. Okay? And one of the things you'll see is there's graphs that contain only one type of symmetry. There could be graphs that don't have any of these, or there's graphs that will contain all three. Okay? And what you'll find is I can't have just two of these. Okay? So if I'm talking about y-axis, x-axis, and origin, I either have all three or I have one, but I can never have two. Okay? And that's again because if I look at it this way, if this is true and this is true, meaning if this is my point and there's this corresponding point x negative y, and there's a corresponding point negative x negative y, well, because of the x-axis symmetry, this point would also have to exist, which means I also get negative x negative y. Okay? And you can kind of reason that for all three of these. Okay? How does this translate to equations? Well, sometimes you're going to be asked whether or not an equation has a certain type of symmetry. And so we can look here. If I'm looking at something that's going to have x-axis symmetry, the way I test it is to use this part of the kind of definition. So I'm going to replace negative y with y, flip that, y with negative y, and see if I get the exact same equation. So for example here, if I take this expression and substitute in negative y for the y, and simplify it down, if I get the same thing, then I know it's going to be y-axis symmetry. And so here we can see when I square a negative, that's the same thing as just y squared. So these And here you'll notice, if I try that with y-axis symmetry, that's not quite going to work, right? If I try to put in a negative x, so 2 times negative x plus y squared equaling 3, I end up with a negative 2x plus y squared equaling 3. So no y-axis symmetry. Okay. And again, with those two right there, I know it's not going to have origin symmetry. Because again, I have one of the two. So I can't have all three. Okay. We can do the same thing here. So looking at x-axis, meaning I'm going to plug in the negative y, I get x to the fourth minus 2x squared plus a negative y equaling 0. But again, when I simplify that, I get a slightly different equation. So there's an extra minus sign in there. So this has no x-axis symmetry. If we try the y-axis, we can see plugging in a negative x for the x's, again, the even powers there make it nice. I get x to the fourth minus an 2x squared plus y equals 0. And again, that's what I started with. So this one has y-axis. And nicely, again, I don't really have to test for origin because it only has, again, one of the two here. So it only has 1. Here I'm actually going to start with origin, just so that you can see how to test it, because you've kind of seen how to test both x and y. So here, if I want to test for origin, the only difference is I'm going to put negatives in for both x and y. And here again, with the odd power, we can see that my sign is going to change, so I'm going to get a negative 2x cubed plus a y equaling 4. Okay. And it almost looks like I should have origin symmetry. But what you'll notice is when I go through with that negative, I end up changing the sign over there. Okay. So this one does not have origin. we can kind of look and see if I put in the negative x there, or sorry, if I put in the negative y there, nope, I said that right, my blue is the negative x. We can see that I'm going to get a negative 2x cubed minus y equal 4, so it has no origin symmetry. And then it leaves one more, that leaves the x-axis, and it almost says, yeah, it's got to have x-axis. But like we said before, it is not necessarily the case that I have any of these. So for example, here when I plug in for the negative y, you can see that my y sign changes, and again, it's not quite the same equation. So again, I can have one of the three, I could have none of them, or again, you could have all three. And the next thing we're going to talk about looks at that. So as I said, circles are those last types of equations that have all three types of symmetry. And so again, if we're looking at both x-axis, y-axis, and origin, it just means if there's a point in the first quadrant, there has to be a point in the second, third, and fourth quadrant as well. And so our definition of a circle is basically it's all points that are equidistant from each other. But we're going to define it by this equation, x minus h quantity squared plus y minus k quantity squared equaling r squared, where hk is the center and r is the radius. And so again, if we think of it in terms of all points being equidistant from each other, what we're looking at is a picture that looks like this, where we'd call this our center. So in this case, our origin is the center, and our radius is just that distance all the way around the outside of that. Okay. So in this picture here, hk is 0, 0. So we would just say x squared plus y squared is equal to r squared. There would be our equation for the circle centered at the origin. Okay. So here let's look at a couple different types of problems. So first, let's say you're given the equation of a circle and we want to find the center and the radius and give a sketch of the graph. Okay. So here our equation, x minus 3 squared plus y plus 1 squared equaling 4. Okay. So again, to pull off the center and the radius, remember it's an x minus h. So our hk is going to look like 3, negative 1. So don't forget the minuses in there make us change the sign. And then for our radius, remember it's r squared. So square root of 4 tells us our r is going to be 2. So to graph, again, we're going to start by sketching the center. Don't forget to label your graph. Okay, so in this case, at 3, negative 1, there's the center of our circle. And then with radius 2, that just means I'm going 2 units in every direction. And so to get our sketch, I'm going to use those main directions and go 2 units in each of those. And so then we can kind of sketch in here what our circle is going to look like. Okay. And again, your circle doesn't have to be perfect. It just needs to look something like a circle. Okay. Again, for our graph, you should have a couple of points labeled. The center we already have, so we just need at least 2 other points. And here, nicely, we can find 4 of them based on what we just did. So if this is the point 3, negative 1, I can see this is the point 3, 1. This is going to be the point 3, negative 3. This would be the point, where's my 6? This will be the point 5, negative 1, and over here this would be the point 1, negative 1. You don't have to label all 4 of those, but again, those are nice, easy points to find on your circle. Okay. And one last example, let's look at this one. So we want to find the center and the radius for a circle whose diameter has endpoints 4, 3, and negative 2, negative 4. And so remember, if we're talking about a circle, the radius is only the distance from the center to the outside of the circle. The diameter is the distance from one side of the circle to the other passing through the center. Okay? So for us, in this case, we know where the diameter endpoints are, meaning wherever my circle is, I know there's a point over here at 4, 3, and there's some point over here at, say, negative 2, negative 4. Okay? And so, in order to find my center and radius so that I can find the equation, I'm basically going to need this midpoint, and I need to know the length of my radius. Okay? So this is where those other two formulas we talked about come in. I need my midpoint, and I'm going to need my distance formula. Well, midpoint's the nicer of the two. So to get my midpoint, I know it's just the average of the x values and the average of the y values. Okay, so here we can see 2 over 2 and negative 1 over 2. So at 1, negative 1/2, there's going to be the center. To get my radius, I want my distance between the midpoint and one of the endpoints. Now there's a couple ways you can do this. If you like the whole numbers here, you can use, or the integer values here, you can use the diameter endpoints, find that distance, and then cut it in half. Or if you don't mind the fractions, you can use the fraction, the midpoint, and one of the endpoints. In this case, since I want just the radius, I'm just going to use the midpoint and one of the endpoints. So my distance formula says I'm going to take the x minus the other x value and square it, plus the y minus the other y value and square it, add those together and take the square root. And that'll give me my radius. So in this case, looking at negative 3 squared, plus over here it looks like a negative 7/2 squared. So that looks like the square root of 9 plus 49 over 4. Go ahead and get your common denominator. Okay, so multiplying by 4, it looks like a 36. So it's going to be 85 over 4 inside our square root. And this isn't going to simplify down perfectly, so we're just going to say that r is going to be root 85 over 2. And there's not much more you can do to simplify that. You can plug that in and get a decimal, but as far as exact answers go, there's our radius and there's our center, and so we're done.